Eric Darling here with Darling Data, and by some miracle I remembered to actually turn on the audio device for this one, so we'll have a full-fledged video and not just me miming away at the screen. That'll be good. In today's extra special video, we're going to be talking about paging queries, because paging queries tie into a lot of the stuff that we've talked about in this series, but most recently the stuff around parameter sensitivity and dynamic searches, because oftentimes paging queries are written in a way that sort of aligns with a dynamic search, and because those things can often be sensitive to parameter stuff, and these things matter. And I'm going to sort of tie those things together with this because, hey, what if someone only watches this video? I don't know. I don't know what to do there. But anyway, if you would like to support this channel, you can. There's a link down in the video description. That's about the end of it. If you don't feel like sharing money with me, you can share some mouse and keyboard clicks. You can like, you can comment, you can subscribe. And if you want to ask me questions that I will answer during my office hours episodes, you can do that at the link right there, which will look startlingly similar to a link down also in the video description that you can click on to send your questions my way. If you need some SQL Server help, well, I do the consulting. I make the SQL Server go fast in exchange for money. Yay, it's fun. Health checks, performance analysis, hands-on tuning, dealing with developer emergencies, and training your developers so that you stop having emergencies and you get to like sleep on weekends and see friends and family and stuff like that, rather than spending the whole time hunched over your laptop wondering what is going wrong and what is wrong with these people around me. If you would like to get some training from me, you can do that too. Of course, I have that available for sale, and you can get that for about for exactly 75% off, which makes the total cost just about $150 US. That's the link, that's the discount code. That stuff is also down in the old video description. Places and things that I'll be yelling about SQL at. SQL Saturday, New York City, taking place May the 10th with a performance tuning pre-con by Andreas Wolter on May the 9th, so the Friday prior to the Saturday. There will be a pre-con. You should attend both. They will be lovely times. Past is going on tour, New York City in August, Dallas in September, Amsterdam and at the beginning of October. All going to be fine, wonderful events that you should also attend, because I'll miss you if you don't. And of course, the big one, the PASS Data Community Summit, taking place in Seattle, November 17th to the 21st, which of course is like, you know, my favorite time of year. My birthday, Thanksgiving, you know, all the good stuff. What else do you need? But anyway, let's talk about these paging queries. It's a really common practice to have to limit search results, and writing paginated queries against SQL Server is a great way to do it. There are alternatives, I guess, if you're some sort of superstar developer where you can, you know, write, I don't know, key set pagine or some like non-server side paging thing. If you want to like return a big result set to your server and page through it over there, I don't know. You're welcome to try that. I don't care. It's your life, you know. But the way that people write them and the lack of indexing for them often leads to pretty disastrous performance issues. So let's just make sure that indexes are gone here. And before, I'm not going to create any indexes yet. I'm just going to kind of walk through a couple ways to write queries and why you should write them this way. And sort of like the differences you might see in query plans with them. So the first thing that you need to understand is when you write a paging query, do not put every column you need in the part of the query that you need to page through. This will make your life a living hell. The easiest way to do this, or the best way to do this, is to get whatever primary key. If your table doesn't have a primary key, you have done something that is going to make paging awful for you. So get yourself a primary key. just get that primary key column. In this case, it is the ID column in the post table. And then isolate the rows that you are interested in, right? Just whatever group of rows you care about, and then join back to the base table to retrieve all the columns. You'll thank me later. This is the best way to do it. If you don't do this, you will most likely end up hitting the clustered index for everything or creating super wide indexes that make your life a living hell. And you will have astronomical memory grants that will make your server cry. So doing this saves you a lot of pain, okay? Just this thing up here. The other way you could do this is with a windowing function. So if you wanted to get some windowing function stuff and just grab this and then filter out the row numbers outside and join back to the post table to get all the columns from there, joining again on the primary key, another totally fine way of doing it. But there is a slight difference between these two methods in the query plan depending on which version in addition and compatibility level for SQL Server you are using. Now, these two query plans, like neither one of these is great, right? Neither one of these puts us in a good place for dealing with a paging query. But one thing that is useful is that when you use the row number version, you can get a window aggregate. Window aggregates happen when your stuff gets batch modey, and this can be very helpful for performance if you have like large result sets and you have like a lot of stuff to page through and you have to keep going back and you want your paging queries to be pretty efficient. When you run it with just offset fetch, you don't get that. You get a top operator because syntactically offset fetch is equivalent to saying top, right? It's the same thing, except with top you can't like offset anything. You can only fetch a certain number of rows. So like that does become a problem if you want to do a paging query, because often a paging query someone might actually want to see the second page, and it just gets a little bit easier to say offset and then fetch. Offset fetch does like often run into performance problems if you get deep into a result set. The thing is that I don't see too many people actually get deep into a result set. Right, it's not very often. You're like, well, I need to go to page 1 million. No one's clicking that much. Anyway, so if you care about potentially getting batch mode on row store, or you are keen on like a more batch mode plan, the row number one is better because windowing functions do have batch mode support, whereas things like top do not. But neither one of those query plans was particularly good. The reason neither one of them was particularly good is because we had to do a whole lot of work to find the rows that we care about. So if we wanted to make this specific paging query faster, then we would like have to kind of come back to things that we've talked about in the last couple of videos with the dynamic searches and indexing for those, and the parameter sensitivity thing, where we need to create indexes that put our data in order that our search queries care about so that they go fast. So let's create this index on last activity date and ID, because last activity date and ID, that's currently our order by. We're going to see how this plays in later, and we're going to talk about how the more complex your where and potentially join clauses get, the harder it is to index for this stuff. So with that index in place, if we run these two now, oh wait, you know what? I still had that index highlighted, so you can skip that part. You'll notice that these results were a bit snappier, right? These things came back a little bit quicker, maybe perhaps even a lot quicker. And now these finished in no time, and we didn't have to do a whole lot of work in order to get our data out, right? Like these query plans are much faster. Like we were able to locate the rows that we cared about very quickly. Everything like made better by this, right? Like having those indexes that put the data the way that we cared about them to support the top here and the window function down here. This was exactly what we wanted, right? Down to the T. Now, this is where things start getting awkward though, right? Because if we just introduce a single where clause element to this, which is going to be owner user ID, and like I know that I am doing this, I'm taking a little bit of a shortcut here with the local variables, but I do have recompile hints on both of these queries so that the local variable effect is non-existent, right? And now, like with that where clause on owner user ID in place, if we rerun these, I don't know why I'm scrolling around so much. I got lost a little bit. This is funny because it's like the shortest script file. But all of a sudden, these things go back to their sort of old performance characteristics. We're no longer using the narrow non-clustered index. We're back to leaning on the clustered index. The clustered index doesn't help us find owner user ID, so we have to scan it with this predicate. And that's true for both of these, right? And what's particularly frustrating is now with this where clause in place, the batch mode on row store window aggregate disappears from this one. We just have this sequence and segment project, sequence project and segment operators, and this this hurts us, right? It burns us. So we don't like this. So this comes back to the sort of like, well, the more complex your queries get, now the more complex your indexes get, because if the more columns end up in that where clause, and depending on if they're equality and inequality searches, like all of it, and like now you have to like balance that with sorting data, and like again, like I have a video, search for equality sort range. You'll find a video on indexing that explains like that indexing strategy. But like just with like one equality predicate, now if we come back and add this, right? This one is owner user ID, last activity date, and then ID. So this is our equality predicate and then our ordering elements. Like doing this, like these things are back to being fast, but now you're kind of stuck with, okay, I still lost my batch mode on row store, right? I don't have the window aggregate operator here. I have the sequence project and segment, and like the whole thing just like it doesn't feel great. So like if you're doing dynamic searches and or paging queries, right? Because like I said, a lot of the times paging queries end up as dynamic searches. Your preference should really strongly be towards non-clustered column store indexes, because they really just help both angles of this without a whole lot of fuss and muss. And without having to juggle like 17 different index definitions to get all these different combinations of where clause, join, sort, group by, whatever else you do in these things. And they handle the unpredictable nature of like, say you don't just want to order by these same two columns over and over again. Say you want to order by something else sometimes. Ditto like here, or like say your where clause might be 5, 6, 7, 8, 9 predicates deep sometimes. Who knows what people will search for, right? Like, so like the non-clustered column store index often is the much better way to go, but like we still have the same difference here where the row number version of the query does have better batch mode support generally. So we hit the column store index in both of them, but this one is back to using the window aggregate. And this one even does and this happened in the query before, I just didn't stop to talk about it. The other nice thing that you get here is you get the adaptive join, which means SQL Server can at runtime to figure out if a hash join or a nested loops join is more appropriate. And so there's even less of a chance of getting something parameter sniffery or parameter sensitivity in here that would end up hurting performance down the line. So the offset fetch version of the query doesn't get that. We use the column store index, and I forget, we still get the sort and batch mode, but we don't it doesn't have like the full, we don't get like the adaptive join for this one. So depending on, how complex your query needs are, like what the performance stuff that goes on with it is, you might be way better off using the row number version over the offset fetch version, because the row number version just has better all-around support for batch mode and batch mode on row store. Not a whole lot else to this story, at least for this thing. The key stuff here is don't select all your columns while you're figuring out what rows you need. Just get your primary key and use the primary key to drive a join back to the base table later. And then, as far as indexing goes, the non-clustered column store handles if your paging queries are unpredictable, then you're going to want that. If your paging queries are very predictable, you could probably get away with just the non-clustered row store indexes, but really just depends on your particular setup for a lot of things. There are a lot of local factors, as a wise man once said, that go into determining what the better setup is. But just understand that there are multiple ways to write paging queries. Some might be better In some cases, some might be better. In other cases, this is the sort of curse of databases, is that you need to test which one works best for your particular situation over and over and over again, because there are just a multitude of ways to do these things. And until you've tested them, you don't know which one is going to be better. And sometimes you have to do a lot of testing across a lot of different cases in order to figure out which one is generally the best or least unacceptable. Sort of like how my wife chose me. She was like, oh, you're the least unacceptable. Great. Approved. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope that you will write your paging queries responsibly, and I will see you for the next and final video in our store procedure series, which is going to be about cursors versus while loops, which, gosh, I hope you're wearing clean underwear, because I noticed generally I hope you're wearing clean underwear, like not because of the video, it's you as a person. Put on some clean underwear. It's gross. Anyway, see you over there in our clean underwear together. All right. Thank you.